Animate and Inanimate by William James Sidis. Chapter 3. Irreversibility. So far, we have seen that the physical laws essential to the determination of the course of the universe from its present momentary condition are all reversible. From this it might be concluded that all physical laws must in consequence be reversible, and that, therefore, there can be no essential difference between the real universe and the reverse universe. And this much is true, that, provided we examine the motions of the particles of matter, everything that happens in the reverse universe can be described in terms of the physical properties of matter as we know them. But at the same time, if we take the most ordinary events of the real universe and attempt to find out what is the corresponding event in the reverse universe, something strange will at once impress us about the reverse universe. Take this, for example: a ball rolls down a staircase, bounces a little at the bottom, and finally stops. In the reverse universe, the initial condition is the ball at the bottom, on a floor near the foot of a staircase. The heat energy in the floor collects at one point underneath the ball, so as to push the ball suddenly upward. Each time that the ball falls back to the floor, this process is repeated, until finally the floor throws the ball onto the first stair. The stairs, each in turn, throw the ball in a similar manner up the staircase, till finally the ball stops at the top. The molecular vibrations in the ball, floor, and staircase had previously been so arranged that concentration of energy would happen at a particular spot and time, while the ball so moved that it just happened to be at those spots exactly in time. So it will be with the occurrences corresponding in the reverse universe to almost any common occurrence in the physical world of our experience. Everything seems to be perfectly explicable in terms of physical laws, but at the same time the combinations of motion seem to have something utterly strange about them. Hence there is some point of difference between the real universe and the reverse universe, and hence there must be some property of the real universe that is irreversible. This irreversible property is found in what is called the second law of thermodynamics. This, taken in its most general aspect, amounts to this: that the energy of the universe is constantly running down to one common level. In other words, where energy of the same variety is present in different degrees of concentration, those differences will be equalized, and energy of a still higher level or to a greater amount must become dissipated in order to recreate these differences of concentration. Of the various varieties of energy, all kinds tend to turn into heat, which is the least concentrated form of energy, and, even though some of that heat may be reconverted into some other form of energy, still, at each step, some energy is irretrievably lost in the form of heat. This physical law, as well as all those which are derived from it, is irreversible. Furthermore, only such physical laws as are derived from the second law of thermodynamics are irreversible, so that this law constitutes the sole difference between the real and the reverse universe. Where, in the real universe, energy runs down to a common level, it follows that, in the reverse universe, energy tends to build itself up into different levels. We may say, then, that the characteristic irreversible part of the universe consists in this, that energy tends to evolve, or devolve, from molar motion of extremely large masses, which is the most concentrated form of energy, to a condition in which all energy is in the form of heat, which is the least concentrated form, and at a uniform concentration, that is to say, at a constant temperature throughout. A final condition would result in which a dead level of energy would be reached, and after that nothing further could ever happen in the universe. The fact, for instance, that perfectly elastic collisions of large masses of matter do not occur, but that such collisions are inelastic, is a direct consequence of the second law of thermodynamics. The characteristic of an inelastic collision is that some of the molar kinetic energy of the colliding bodies is lost by the impact. This lost kinetic energy is changed into heat, which is always produced by an inelastic collision. This is in strict accord with the second law of thermodynamics. In the reverse universe, on the contrary, an impact would be an occasion for heat to be converted into molar motion, thus increasing the total amount of kinetic energy. Such a collision we may call superelastic, and is not within our experience. Again, the resistance offered by one body to another, whether in the form of friction or otherwise, is but an example of the second law of thermodynamics, being another case of change of molar energy into heat. In the 19 reverse universe, the very opposite process would take place. Accordingly, we find, as might be expected, that the laws of friction, etc., are irreversible. Many chemical reactions are irreversible, though some are reversible. As a general rule, the irreversible chemical reactions are cases of conversion of chemical energy into heat, in accordance with the second law of thermodynamics. So with all irreversible processes. In the case of a machine, the ratio of the energy obtained to the energy put in, usually expressed as a percentage, is called the mechanical efficiency of that machine. The remaining energy, that the machine has lost, becomes heat. The second law of thermodynamics, expressed in terms of mechanical efficiency, means that all physical phenomena have a mechanical efficiency of less than 100%. The reverse universe, on the contrary, is distinguished from the universe of our experience in that the mechanical efficiency of its phenomena is over 100%. Again, to express it in another way. Suppose two bodies, one at a temperature of 0 degrees Fahrenheit, the other at a temperature of 200 degrees. The only available heat energy in those bodies would be the amount represented by 200 degrees in the hotter body. At the same time, the colder body being 460 degrees above absolute zero, there is unavailable energy, which, according to the second law of thermodynamics, cannot be reached, amounting to 460 degrees in each of the two bodies. If both bodies have the same mass and specific heat, the energy which, under the second law of thermodynamics, is available for conversion into other forms of energy, could thus be represented by 200, while the total heat energy in the two bodies would be represented by 460 plus 660 equals 1120. The ratio of available to total energy in this case would be 200 to 1120, or 5 to 28. In other words, only 18% of the total heat energy is available for conversion. The second law of thermodynamics states, not merely that not all the available energy can actually be used for any purpose except heat, but also that all energy in an available form, a form other than heat, or else heat energy in the form of a difference of temperature, tends to turn into unavailable energy, that the amount of available energy in the universe is constantly decreasing. In the reverse universe we have a different situation, since the second law of thermodynamics is irreversible. Even the heat energy below the temperature of the coldest bodies in the environment is not merely available, but constantly drawn on. The same immense fund of energy which in the real physical universe is constantly stored up and unavailable, now ceases to be unavailable, but becomes a reserve fund of energy with which difference of concentration of energy is constantly being built up. Under the second law of thermodynamics, a reserve fund of energy is constantly stored up in the form of heat and never afterwards touched. Under the reverse of that second law, on the contrary, we start with this reserve fund of energy and constantly draw on it to build up energy differences.